Looks like you made it, John.
Oh, sort of. We're coming up Embarcadero on the way to campus, but I have my technology plan B is working.
The internet never works great for me on Embarcadero, so that's also
yeah, I'm a little worried about that. So start if I fade out and don't get a chance to introduce you, plan C is you get to start yourself.
Got it.
Things are a little wild this morning. I'm watching the participant numbers steadily grow, so we'll let that follow the S-shaped diffusion, and then we'll get going.
And John, do I remember correctly? I plan to talk for roughly an hour with interruptions, and then we end and people hang around for questions for a little bit. Is that the plan?
That's probably fine. But we definitely have a hard stop at noon. But other than that, it's probably wise. So people tend to like to. It's the game of Jeopardy. It's really a speech, but you try to phrase it as a question, and especially with your topic. So leaving some time for people to ask you larger questions, I think, would be very useful.
Chad, David Henderson here. Are the ground rules we ask clarifying questions, or does it include substantive questions?
I think you should ask whatever you want. It's much more fun that way. So
okay,
yeah.
Great, thanks.
Ask whatever you want, but please don't head off on long tangents if you don't absolutely have to. Economist rules with restraint. How about that? So I think we're close enough to get started here. We have lots of participants, and we believe in the trains running on time. My job is to introduce. This week we have Chad Jones to talk to us about long-run growth. I want to advertise for the rest of you. Nothing matters except long-run growth. I'm embarrassed to do inflation in my own work because it doesn't really matter one bit compared to what Chad does, but it's where I know the answers. So this is really, and Chad's asking deep questions about long-run growth. So
I think we just.
I'm especially glad.
Great. So thanks very much, John. Oh, you're breaking up a little bit, so I can't tell what you're saying.
Go.
All right. Good. So thanks a lot. With the usual Zoom format, I can't really see all of you while I'm presenting. So feel free to just jump in and interrupt whenever you'd like, or raise your hand, and I think that should flash on my screen. But if I miss it, feel free to jump in. So one question I had was, why am I talking in the classical liberalism seminar about this topic? And I thought for a few minutes about it. And I think it fits in very much with a certain view of your seminar, which is, classical liberalism is a set of principles and we think about the economic implications of those principles, I guess among other things, this is very much a paper in the same spirit. There's a principle, utilitarianism, the greatest good for the greatest number. And what are some of the implications, the economic implications of that principle? And let's kind of explore it. So this is joint work with Pete Clino, Mark Bills, and a graduate student in the economics department, Mohammed Adami. Okay, so as John mentioned, I work, almost entirely on economic growth, and kind of pretty much universally, economic growth is measured in per capita terms. And there are lots of good reasons for that. We don't want to, say we should never do that at all. But the fact that we never do it any other way might raise some questions. And so in particular, this focus on per capita economic growth, growth in GDP per person, puts zero weight on having more people in the economy. And that's obviously at one extreme. And the more you think about it, the more you might be bothered by that. So one way to think about it is, suppose we hold per capita consumption constant and consider two worlds, a world with 1 billion people and a world with 1 million people. Well, the world with 1 billion people seems better in some sense. And so, it's sort of ideas like that we're going to explore in this paper. So another way to think about this is, imagine two countries that have the same time series for total factor productivity, right? So total factor productivity is the key to economic growth, one way or the other. And so if we say these two countries have the same total factor productivity, they have the same production possibilities, right? But imagine they make different choices, so that one country has constant population and all the productivity growth goes into rising consumption per person, but the other country chooses to have constant consumption, but rising population. Okay, we sort of set things up so that they have the same production possibilities. So it seems like they ought to be equivalent in some sense, or maybe. But our normal focus on per capita growth would say one country is doing so much better than the other country. Okay, and this is not just a hypothetical. They're real world examples that very much parallel, the simple example. So Japan is 6 times richer today than it was in 1960, and Mexico's 3 times richer. But Mexico's population is 3 times larger than it was in 1960, while Japan's population is only 30% larger. Right? So which country's been more successful at creating economic welfare for people? It depends on how much weight you put on one versus the other, and putting all the weight on consumption per capita seems extreme. Another example I like a lot is that if you think about economic growth before the past 2 centuries, for thousands and thousands of years, economic growth showed up on the extensive margin, higher population, not higher per capita income. And notice, it wasn't because technology wasn't improving. We invented, fire and stone tools and the Bronze Age and, cities and agriculture and everything else. There was progress in total factor productivity. It just showed up on the extensive margin. So if you want to think about growth over this long period, you need to think about how to come to grips with this extensive versus intensive margin. So the big picture question here is, how should we think about the contribution of population growth to some aggregate economic welfare measure? Okay, and there are lots of examples of how you might use the ideas in this paper. The Black Death or HIV or COVID-19, all of these killed large numbers of people. That's a disaster from some standpoint, maybe not from the per capita consumption standpoint. In the Black Death, per capita consumption went up, but that's probably not the right measure of economic success. Or China's one-child policy, or what fraction of GDP should we spend today to mitigate climate change 100 years from now? Well, the answer to that question surely depends on how many people there are going to be around in the year 2100. If there are 20 billion people in 2100 versus 1 billion people, that's going to change how we think about moving resources from today to solving this problem. Similarly, how much to spend to avoid existential risks, so asteroids or nuclear war or other kinds of things, existential risks that might end human civilization, there's potentially billions of people years in the future that would be ended. Will McCaskill wrote a recent book about this, so this has been in the news a lot lately. So all these things require coming to grips with this question of how to include population in our measures of economic welfare. Okay, importantly, let me highlight what we're not doing, because this is a natural point of confusion here. So what we are doing is, in some sense, we're going to use the marginal rate of substitution in aggregate welfare between people and per capita consumption to value these things. We're looking at an indifference curve between people and per capita consumption, and we're valuing things along that indifference curve. There are lots of other questions where you'd need to use the production possibilities as well, the social marginal rate of transformation on the production side. So think about, more people gives you more ideas, which raises per capita consumption. I'm a big fan of that notion. Investments in human capital or pollution, anything involving the production side, we're not going to look at. Okay, so questions of optimal fertility, we have nothing to say. Was the demographic transition good or bad? We have nothing to say, because we're not bringing in this production possibilities half of the world. We're only looking at the preference side of things, and this has costs and benefits. We're going to do accounting with total welfare. The benefit is you need a lot fewer assumptions. We don't have to make any assumptions on the production side. That said, there are a bunch of questions we can't look at for that reason. And in future research, we or other people should certainly look at those other questions. But just want to be clear about what we're doing.
Chad, I'm sorry. I'll just a very brief question.
Sure.
If total population's increasing to such an extent that total welfare has increased, but per capita welfare is going down, would you call that an increase in welfare?
Well, that's the kind of question we're going to address. We'll answer that in just a second, but it depends. Obviously, it depends on how big the increase in population is and how small the decline in consumption is and how you trade those things off. So our method will allow you to answer that question very clearly. Okay. All right, so what are we doing? We're going to do sort of part one, which is probably where I'll spend 90% of the time. We're going to do a baseline calculation looking at population and per capita consumption. Part two, we'll think about adjusting for migration. So we're going to do some exercises with different countries and who gets the credit for the kids that are born in Mexico and migrate to the US. It turns out things are very robust to that, the numbers. Part three, you might ask, well, parents only have kids because they love them and there's endogenous fertility, and you could enrich our framework by thinking about those questions. So we have a third part that does that and works with some microdata to make things more precise, and things are pretty robust in that dimension as well. Okay, so that's where we're going. So let me tell you about this the setup. So importantly, we're going to think about the flow of aggregate welfare, not the stock. So I want you to think about your lifetime utility, which depends on your consumption stream today and into the future, versus the flow utility you enjoy today. Notice that GDP per person or consumption per person, the sort of macro statistics we're used to looking at in the growth literature, are all flow concepts. In parallel, we're going to think about the flow of aggregate welfare, not the present discounted value of lifetime utility that depends on the future that's sort of hard to measure anyway. Okay, so that's one thing. The simple setup that we start with, CT is consumption per person. U of CT is the flow of utility enjoyed by each person. In just a second, I'm going to explain why it has to be positive. And the economy consists of NT identical people. Okay, we can think about heterogeneity. In other work I've done with Pete, we thought a lot about the heterogeneity. That's not first order for the question today, so we're setting it aside, but you could certainly bring all that stuff in. Okay, so each person gets CT consumption, enjoys U of CT as their flow of utility in period T, and they're N of these people. So summing over the people, the aggregate flow of utility in this economy is N times U of C. Okay, and we're going to call that aggregate flow of utility W. And you'll notice it looks a lot like a total utilitarianism social welfare function. If you prefer to think about that, philosophical concept, that's totally fine. That's kind of how we started. But I think just, how much flow utility is generated in this economy? Well, if there are n people and each one has U of C flow, it's n times U of C. I think that sort of more prosaic interpretation is helpful just to think about. So two things to notice here. Notice that non-existence, not existing, is valued at 0. And that's a combination of a free normalization and an assumption. The free normalization, you could choose units. So we choose death to be normalized to 0. You could make death negative 40,000 or death 6 million. That wouldn't change anything. There is an assumption, though, which is the assumption of not ever existing is the same as the assumption of being dead. It's the same with the utility of being dead. So there's an assumption there that philosophers have thought a lot about and sometimes get bent out of shape about. I think for an economist, this is sort of a natural way to do things. That's the way we're going to do it. Okay. Some philosophical things that come in. This total utilitarianism approach has been criticized because of the repugnant conclusion. Namely that you'd like to have a world of a gazillion people, each who are just epsilon, better than being dead. And is that a problem? I think the philosophers have decided maybe it's not such a problem, and that's certainly our view. Inalienable rights, there are all sorts of rights that you wouldn't want to use this as a social welfare function for every possible moral decision you'd have to make. Of course, that's true. It's still a useful thing to do relative to putting 0 weight on people. That's kind of our approach. Another thing that's worth appreciating is this sort of per capita utilitarianism or average utilitarianism. That's what the growth literature always does. My earlier paper with Pete looked at per capita stuff and valued things. That's a really weird approach if you think about a world with people. So the sadistic conclusion is the notion, in a world where you only care about the average, you should kill off everyone and give all the resources to one person. And so, those kind of things would be good things, which seems completely crazy to us. So this sort of n times U of C approach, I don't want to claim it's the be-all and the end-all answer to every question you want to ask, but I think it's a useful way to approach this problem of, how should we value people? All right. So
Chad, I'm wondering, why do we need this structure? Why isn't this just a revealed preference question? Value of a statistical life on the back end, or you've equated it to birth. So, families making choices about size of the family.
Yeah. Excellent question. We're going to use the value of life, absolutely in our calculations here. So that's going to be here. Notice the revealed preference approach is a little bit tricky, right? You and I have kids because we love our kids. It's our utility that determines how many kids we have. Our kids' utility, suppose I don't want to have any kids, that's that my revealed preference is going to say I don't have any kids, but maybe if I did have a kid, that kid would value their life, right? So how much the kid themselves values their life is something that revealed preference can have trouble with. Now you can infer it from how much people who are alive avoid dying, right? That's exactly what we're going to do here. When we try to value these lives, it's going to be valued exactly that way.
So you're using the structure from the VSL literature. It's not
absolutely. You're going to see that in just 2 slides, I think. Okay, so W equals n times U of C. Right, let me go back to this. Take logs and derivatives of this, right? So the growth rate of W is going to be the growth rate of n times the elasticity, which is 1 there, plus the growth rate of consumption times the elasticity of utility with respect to consumption, right? So that's this first equation. The growth rate of social welfare is population growth, since the elasticity is 1, plus consumption per person growth, multiplied by, du dc times c over u. Okay? Importantly, so if you want to go through the consumption equivalent welfare calculation more carefully, you can, and you're going to get the answer that I'm going to give you here. The way to think about it is welfare growth is measured in whatever units have a coefficient of 1 in front of them. So it turns out this dW over W, our social welfare function here, is measured in population equivalent units rather than consumption equivalent units, because the coefficient on population growth is 1, and we downweight, the coefficient on consumption growth according to the elasticity of utility with respect to consumption, because diminishing marginal utility, that that elasticity is less than 1. If you want to get things in consumption equivalent terms, you want the coefficient on consumption growth to be 1. So we just divide by this elasticity of utility. Okay, and that gives us this equation. And again, you can do this more formally and get exactly the same answer. Consumption equivalent welfare growth is per capita consumption growth plus population growth times a coefficient. And that coefficient we're going to call V of C. And notice V of C is the inverse of the elasticity of utility with respect to consumption. That's just the mathematical version of it. It has a good economic interpretation. Murphy and Topel, for example, have used in some of their work in valuing lives and thinking about investing in research to cure diseases. Namely, what is V of C? So it's U of C. That's the value of one person living a year of life. And we divide it by the marginal utility of consumption. So that puts it in consumption units. So it's the value of year of life in consumption units relative to per capita consumption. Okay. Another way to say what I just said is V of C is the value of year of life measured in years of per capita consumption. Okay, and this will be more clear when I put some numbers on it. But in other words, saying it, 1 percentage point of population growth is worth V of C percentage points of consumption growth. And we have to figure out what this V of C is. Okay, and that's the next slide where the value of life is going to come into play. Okay, so to start with, let's get V of C for the United States in the year 2006. And the reason we've chosen this country in this year is the Environmental Protection Agency has numbers that they use for the value of a life to make all sorts of decisions. And these kind of numbers are used all the time in litigation. When someone dies and they have to decide what the compensation is, the value of life is a key number. So there's hundreds of studies that have estimated these kind of numbers. And typically they do things like there's a janitor and there's a construction worker, and the janitor could have been a construction worker, but doing construction is a lot more dangerous than being a janitor. So what's the compensating wage that you have to be paid to be a construction worker relative to the extra probability of death you're incurring? And you can back out a value of life from those kind of calculations. And the EPA's sort of value that they use, and this is very much consistent with a lot of other values. We'll look at some robustness that I won't emphasize, but we'll look at it. They used $7.4 million in 2006. And you can think about that as the value of life for kind of a middle-aged American. So someone who's 40 years old, the present discounted value of the next 40 plus, 50 plus years, whatever, is in economic terms worth $7.4 million. So this V of C, it's U of C over U prime C. Well, you can think about it as the value of a statistical life year. So the U of C is just 1 year of that potential 40 or 50 years in the future. So think about that as the VSL, the 7.4 million divided by life expectancy at age 40, which is about 40 years. So 7.4 million divided by age 40. Per capita consumption in the US, when you include private consumption and government consumption, because we're going to look at countries like France, for example, where a lot of health spending or education spending or other spending is done by the government. So we wanted to think of all the consumption together. This gives you $185,000 for the value of a life year, which is consistent with the kind of $100,000 to $200,000 numbers that Cutler and other people use in this value of life literature. Divided by 38,000, that's about 5, right? So V of C for the United States in 2006, using very conventional numbers, is some number like 5. 1 year of life.
What happened to the U prime term?
Okay. So the U of C is measured in utils. To convert it to dollars, you divide by U prime of C. So U of C over U prime of C is the value of a life year measured in dollars rather than utils.
Chad, this is a cardinal utility question, not a purely ordinal, right? And
Absolutely.
so
absolutely.
we're in standard utilitarian. We believe there is such a thing as cardinal utility. Yeah.
Yep. Totally. That's definitely true.
But you don't need to worry about that because you got everyone the same.
No, you do have to worry about that because you're trading off utils versus life, and that's a cardinal question, not a revealed preference question, unless people are volunteering for suicide in return for money.
Yeah, we're going to take this N times U of C very, very seriously and put numbers on it, and everything's going to be cardinal.
I don't follow that. I don't follow that part. We have in the real world people making trade-offs,
Right.
and they have the same. Usually, we set up the same structure that they have. You know, some probability, and in the law of large numbers, that'll be numbers of people times what you get if you're alive. And
yeah,
see the cardinal.
So we're going to have to extrapolate this. You don't see it yet, but we're going to extrapolate this over time for the last 50 years and across countries, and that extrapolation is going to, if we, another way of saying what Casey's saying, I think if we had measures of V of C at all dates and places, then we could, I think there'd still be a cardinal sense, but
Ken has a question.
Yeah, so the question is, so I worry that you're sort of overstating the value of consumption here, and the reason is, like, if I think about, like, if I die on the job or something like that, it's not just my foregone years of living that I'm concerned about, it's the fact of dying in a way that is surprising. And and I think the way that most of these values of a statistical life are calculated, there's a tragedy associated with dying young in most people's minds that probably factors into their decisions and the trade-offs that they make. So I worry that you could be vastly understating the number of years of per capita consumption that a year of life is worth in that sense. I'm not sure if I'm getting that quite right. I'm not sure how that's going to play into what you're going to do later.
That's related to the assumption that it's the same thing to never be born as to die is a very troublesome assumption.
Exactly. Yes, John.
Yep. No, I agree with both those statements that's potentially relevant here. In part, what alternative would you like me to explore? And we'd love to explore it. I think is the
this is the natural first step. Yes,
yeah,
exactly.
Totally fair point.
Exactly. I think whether this 5 is too large or too small, I think is an interesting question. You might think that it sounds like you're arguing this is too small, and this being too small is great because we're going to get huge results, and you're just telling me they're even bigger. If this is too large, then I'm more concerned. And I think you could have asked a different question where you would have framed it such that you think this is too large, which I'm open to. So I'll show you some robustness with different numbers.
The value of more new people versus the value of killing people is that's a very hard one that is equated here.
Yeah, no, that's right. But if you think about it, it's kind of like running time forward versus backwards, right? Yeah. And it's the symmetry is, we have. I think again, I'm open to alternatives if there were a good one. It's not obvious there's anything else that's nearly as focal as this.
Well, most of your applications are about adding new people, not about killing.
Yeah, but you're still taking them from non-existing to existing rather than killing them off, and so it's I think it matters. Another thing I want to say about helping you think about this thing, go back to. Suppose U of C were linear in consumption. Suppose U of C were just equal to C. Then this V would equal 1. Okay. Suppose U of C were the square root of C. Right. So the elasticity is 1/2. V of C is the inverse elasticity. V of C would be 2. Okay. So the more diminishing returns there is, the higher this elasticity. And so, we're calibrating and we're saying 5 for the US in 2006. I'll show you the US over time and other countries. It's going to be different, and this is coming. But basically, notice an implication. You can already see why the numbers are big. 1 percentage point of population growth is worth 5 percentage points of consumption growth. Right? So the US is growing at 2% per year. We have population growth of 1% per year. Our consumption equivalent welfare growth locally is going to be, 7, 2 plus 5. So the population growth, this weight of 5 is huge. People are incredibly valuable. If you ask why it is, it's because of this diminishing returns. U of C has really sharp diminishing returns for our conventional utility functions. Lots of people would say it's bounded. Right? We're going to take log utility for our baseline case on the next slide. Lots of people would say it's bounded. If it's bounded, right, well then, kind of adding more people is the only way to increase this W in the long run.
Chad, could I don't want to interrupt you too much, but this seems to have the clear implication that as you get richer, you value people more. But as societies get richer, their birth rates plummet. I presume you're going to get to that, or?
Yeah, the next slide is we're starting to talk about it.
But Chad, the only thing is, it's a strange thing. It's basically saying, okay, I'm rich and I'm going to now choose an iPhone. And you're saying, yeah, it's a totally immoral decision because you're choosing an iPhone and rather than letting somebody be born. The real problem is that person who's never been born never knows it. So there's this sense of giving preferences to people that would never have those preferences.
Absolutely. Notice it's interesting because once the people exist, we endow them with all sorts of things. But, when we're thinking about how much to spend to, avoid existential risks that might end the earth, you'd like the people 500 years from now to have a vote on that because it's their lives we're not allowing to be born, but they get 0 votes. And this social welfare function kind of gives people votes is a way to think about it.
Yeah, I agree. But I think you're making a very stark point here, which I think is a good point, which is, giving up an iPhone isn't much if you put preferences on non-living people's preferences in the future.
Yeah. John's point's coming, as well on the next slide. And, it's going to be very important conceptually to distinguish what N times U of C wants versus what I, Chad Jones, want. When I'm deciding how many kids to have, I'm thinking about maximizing my own utility. I'm not thinking about, I have kids because I love them, but I'm not thinking about the fact that they love existing apart from how much I love them. And so I think that issue is in the background here. Okay, but this point that John was making first about, you'll see now. So if we want to measure V of C in other years and countries, we don't have good data in other years and countries. And so we're going to use a functional form to extrapolate. Okay, and this is, this is useful. So we had data, we could check this functional form, but our functional form is going to be, again, the least controversial one I think we could pick, which is log utility from consumption. Okay, U of C equals log C. Notice I've put a U bar in front, and you're going to see that U bar matters. You can't do without it. The assumption that U bar is 0 is not something you're allowed to make. We can reject that very obviously, and for reasons you'll see in a second. We're not used to thinking about it because we don't usually think of any economic decision multiplying U of C. But now how many people do you want to have depends on the level of utility, and so it depends on U bar. Okay, so with this utility function, notice V of C. Well, U prime of C times C is just 1, so V of C is just U of C. So the value of life measured in years of consumption is equal to U bar plus the log of consumption. And absolutely, as people get richer, the value of a year of life gets higher, even measured relative to years of consumption. So again, the way I like to think about this is, think about, C to the 1 minus gamma over 1 minus gamma, where gamma is 2, right? So C to the 1 minus gamma, it's C to the -1, it's -1 over C. Flow utility is bounded for our standard constant relative risk aversion bigger than 1. Flow utility is bounded, right? And so, adding more consumption just runs into incredibly sharp diminishing returns. And so the value of life rises relative to consumption. Value of life rises because we get richer, but it rises even faster than consumption for c to the 1 minus gamma, or gamma is bigger than 1, this example shows even for log utility, the value of life rises with consumption, right? Even measured in years of consumption. Okay, you're going to see that in a second. We're free to pick units. So a free normalization is in what units to measure consumption. Do we measure it in dollars, in 2023 dollars, or in 1980 dollars? We're going to choose units such that consumption in the US in 2006 is equal to 1. And that's because that makes immediate what the value of U bar is, right? So log of 1 is 0. So the value of life in 2006 for the United States that I told you on the previous slide was 4.87. That implies U bar is 4.87. Okay. And then this utility function implies that the value of life rises linearly if consumption exhibits exponential growth. Right? So the value of life is going to rise linearly at something like 0.02 per year, right? Because consumption growth is 0.02 per year in the United States. Okay, so if we just take data on per capita consumption over time, we can plot what V of C looks like. Oh, there's some alternative calibration here. I'm going to skip that in the interest of time. Here's V of C for the US back to 1820. Okay, and you can see the red dot is the 4.87. And you can see this looks kind of like a straight line because consumption is growing exponentially. And so the log of consumption is a straight line. Importantly, notice in 1840, one second, in 1840, the value of a year of life was about 2 years of per capita consumption, whereas now it's about 5 years of per capita consumption. Question?
Just and realizing from your calculations, by using the value of statistical life, you're also saying that extending an existing person's life a year is the same thing as bringing birth to a new person who lives an extra year, right?
Yep. Anytime you get an extra U of C, we're valuing that U of C with this V, right? And that could be extending a life, bringing a life in, or whatever, right? So
whereas people might feel differently about those things.
They might. It's
in your next paper.
Yeah. It's if notice, by the way, if you're worried about, hey, we have abortions, or infants the day they're born, if they die, it's not as bad as if they die when they're age 5. All that stuff is fine. If you want us to say life starts at age 5, all our calculations would be the same. It wouldn't make any difference at all. So
I was thinking more about, do you want to spend $1 trillion to extend my life 10 years, or do you want to spend $1 trillion on bringing some new babies in the world? Personally, I've got feelings about that.
Yeah, exactly. This is where this behind the veil of ignorance thing is kind of useful here. Okay, what about applying it across countries? So look across countries in 2019 using the Penn World Tables. The US again is close to 5. There are lots of different countries. Ethiopia is around 2. So the value of a year of life in Ethiopia based on their consumption using the same U bar. So U bar is a preference parameter. People are people all over the world. Everyone, the way we're going to value things at least is using a common set of preferences. I could talk more about that if you want, but I think that's probably a useful thing to do. And the value of year of life in Ethiopia is about the same as the value of year of life in the US in 1840.
Ken, you could put this more politely by saying the value of consumption in Ethiopia is much higher than the value of consumption in the US.
It's much lower, yeah.
The value of consumption is much higher rather than saying the value of life is much lower. I'm just trying to get you not desk rejected.
Yeah, no. I mean, I think, I prefer this way. I agree. There's a danger. There's a big danger, and I mean, we'll do a robustness check to this in just a second. We're going to value lives according to that social welfare function that says a life in Ethiopia at a low level of consumption is worth less behind the veil of ignorance to this social welfare function than a year of life in Germany. And we may find that offensive or not. It's what the math says, so we're going to do it. We'll also value all lives the same way. And I'll show you, it matters sometimes in places, obviously. Ethiopia is going to be a good example. And, you're free to pick whichever one of those ways you like. One has good micro foundations, but seems counter to some of our things.
What you mean by that is the value of a life that has very low consumption in it is less than the value of a life that has very high consumption in it.
Exactly.
Equivalently, the value of giving a given life more consumption is very high.
Exactly.
Okay, yeah.
Exactly.
Chad, it doesn't affect your calculations, but I don't think you can hang on to this idea that, well, a child is worth more than what his parents value it at. Because then aren't you into the Ramsey situation where per capita consumption ought to be discounted at 0, and therefore aggregate consumption, you're not going to have anything bounded anymore. And certainly you can't use a lot of the revealed preference that allows us to aggregate and all that stuff because we got the wrong intertemporal discount factor by Ramsey and Chad's philosophical view.
I think the discount factor is a different point. I agree that it's a natural point to bring up. I don't think anything we're doing says anything about the discount factor. If you notice, we're sort of looking at the cross section at a point in time, and we're now when we compare things over time, we're not gonna do any discounting. So I guess you're right that we are sort of. Let's think about that.
No, you're doing the question, what is the consequences of NU of C? And
yeah,
I really like this. And we're all just objecting to NU of C when we see the answers, but I think it's the right way to, let's start with what's the implications of NU of C.
Yeah, but we're going to compare NU of C today versus yesterday, today versus tomorrow or something, and we're not doing any discounting there. So I don't know if we, putting in the discounting wouldn't make it barely make any difference, I think, but for the year-to-year comparisons. But that's an interesting point. Okay, so just to recap where we are, but next I'm going to show you data. That's the rest of the paper. The growth rate of consumption equivalent welfare. So everything's measured in consumption units. That's, I don't know what utils are. I know what dollars of consumption are. So everything's measured in consumption equivalent units, the way Lucas and other people taught us. It's V of C times population growth plus the growth rate of per capita consumption. Okay, and this V of C comes, I just showed you all the V of C numbers in some sense. Notice if V of C were 1, consumption equivalent welfare growth would just be aggregate consumption growth rather than per capita or something. But I just showed you all the numbers. Everywhere we look, V of C is much larger than 1, and so aggregate consumption growth would give you a misleading answer. It could still be interesting, and I'll show you what difference it makes in certain times and places. Okay, but the weight on population growth in Ethiopia is 2, in the US today is 5, and in different countries at different points in time, it's some number between 2 and 5, but it's a lot bigger than 1. So when we're thinking about these growth rates, population is going to play a key role.
So Chad, it's hard to not notice that the actual reality is exactly opposite, right? So it's in the United States where the marginal benefit of $1 is lower, so you should increase the population, where the population is growing slowly. And in Ethiopia, or at least Southern Africa, the marginal benefit is much higher, so you shouldn't increase the population, where it's growing faster.
Absolutely. So John brought this up before, and I kind of skirted over, but let me address it. So this question's bothered me for the last decade because I've been playing with these V of Cs in lots of different contexts, and your question's the one that bothered me the most. The answer, we'll sort of come to it a little bit in that part 3, but we're not making it explicit. The first thing to say is, just like I said, optimal fertility is off the table. I'm not saying anything about what the production function for kids is. I think the other thing I'm not saying, I think the real answer is, I have kids because I love them. That love, that Barrow-Becker love, is in my U of C. So the planner wants to have kids entering the social welfare function additionally, okay? And so it turns out, I think one interpretation is there's a massive externality here. Parents in the US and Ethiopia have their kids because they love them. Evidently, as time gets expensive, we don't love kids that much, so we're having fewer and fewer of them.
I think
the planner loves kids directly, they values kids directly, not just because we as parents love them. And in fact, the planner puts more weight on kids because the planner values me and I love my kids, but the planner also values my kids directly. And so my interpretation of the facts of the world is, according to this social welfare function, there's a massive externality.
Chad, wouldn't another, you said you didn't want to talk about migration, so maybe you don't want to get to this, but wouldn't another implication be that you allow lots of people from Ethiopia to come here?
I think that's true just on the per capita consumption basis. I think that's more about other things, like, working with good institutions and with better technologies. I think that's separate from this paper. This paper, yeah, but your question, that's exactly why I have the migration assumption that, if lots of people move to the US, do we give the US credit for producing them, or do we give Mexico the credit? And, our default calculation, all the numbers I'm going to show you, values people based on where they live currently, not where they're born.
Yeah.
We do things a completely different way, valuing people where they're born. And it matters a little bit for some countries, but doesn't make much difference. But
Well, I mean, one thing is their productivity multiplies 5 to 10 times. When
yeah. No, so I totally agree with that. I think that's an important point. It's just, that's in the C in some sense here. And so we're taking the C as what it is. And that point's true, but it doesn't bear directly on our calculation so much.
Chad, one last thing. I think also a deep philosophical question here, because the reason I want to have kids is my genes have been naturally selected to give me a preference to have kids, but there's no reason that's a moral preference.
Absolutely. That's another way of saying this N times U of C social welfare function. There's no reason why, evolution selected us to have that social welfare function. So my view is exactly what you said, that, biology gives us some preferences about kids, and that may be the wrong preferences behind the veil of ignorance from this N times U of C standpoint. Anoop, I see your hand as well.
Yeah, I have two questions, and I think you've kind of answered one. So here's the first question is, if you look across countries holding income constant, you could imagine that some cultures value having larger families more than other cultures. So you see that in the United States across religions. I think your answer to that is, yeah, that's fine. That's kind of folded into my estimate of U of C, and I'm looking at aggregates. And okay, all right. So that's the first one. And but the only kind of pushback I'd say is like, how completely is it included? Okay. The second question is just trying to for explaining this paper to someone else that's a Malthusian who says, oh, that extra kid is sharing the existing resources. How would we write this model differently if we didn't think an additional human gets the same per capita income?
Perfect. No, this is a really important point. We're taking the C as the data, and we're taking the N as the data, and we're valuing them on this social welfare function and difference curve. We're not saying anything about the production function. So if you add more people, how does that change C? I have no idea in this paper. I have thoughts about it, obviously, but in this paper, we don't have to address that because we're just taking the social indifference curve and looking at the N and C combinations that we see in countries and kind of putting them in consumption equivalent units.
Well, I think you are, because you're implicitly assuming that I can add one extra person without changing the per capita income of anybody else. And that's it's an assumption that has to exist for you to get like, an N times C type situation. But like if I was Paul Ehrlich, I would come along and say, no, you add and you go from N to N plus 1, the C has to decline for everybody else.
Yeah. I mean, this is a derivative question in some sense. Everything's kind of small changes. And so it kind of roughly works out. But, I think we could, I think because we're doing it with small changes, it would probably be okay. No one thinks the effect is huge from, you add one person to the US out of 330 million people. How much does per capita consumption change? Not very much. Okay. All right. Okay. So Penn World tables for 100 countries, and then Madison data for longer time series, and Barrow or SUA for the US as well. I should have said the things that I showed you before. Okay. So for 100 countries from the Penn World table, 1960 to 2019, per capita consumption growth in this sample averages just over 2% per year. Population growth averages just over 1% per year. I'm sorry, just under 2% per year. So it's roughly 2 and 2. Okay. we've got our baseline that I showed you with U bar equals 5, and then we've got some robustness to different values of life, but I'm not going to talk about that. Consumption equivalent welfare growth, right, is going to be this 2.1 plus V times 1.8. And the V turns out to be some number like 2.7 on average. You saw that in the cross-section graph that I showed you for 2019. And so, consumption equivalent welfare growth is 6.2% per year rather than 2.1% per year that you have just from looking at per capita consumption. What share of this is due to population versus consumption? About 2/3. That's weighting by countries. If you weight by population, China gets a huge weight, and China has really low population growth because of partly their one-child policy. And so the population share would go down to 51%. What fraction of countries have population shares that are bigger than the consumption shares? 78% of them, because there are 101 countries. Okay, let me show you some data now, but for individual countries. So first, Mexico. On per capita consumption basis, 1.8% per year, nothing special, kind of, below average for developing countries probably. Population growth is 2% per year over this period, 1960 to 2019. Mexico's, modestly, in the middle of the income distribution for the world. So its V is around 3.4. And so consumption equivalent welfare growth is 8.6% per year. Okay, with about 80% of that being due to the population component. So the population component is a big deal. Let me skip Brazil and South Africa. What about the US? 2% consumption growth, 1% population growth, but the V of C on average over this period is more than 4. And so consumption equivalent welfare growth in the US is 6.5% per year, with about 2/3 of that due to the population component. What about China? Well, interestingly, China's consumption equivalent welfare growth is lower than the US rather than higher. They're a growth miracle. We're going all the way back to 1960 here. I'll do some later numbers. 3.8% consumption growth, but population growth is pretty low. And because China's poor, you're adding people at low levels of consumption, so that's not worth as much as it is in the United States. And so their consumption equivalent welfare growth is just 5.7%. I'll come back to Japan in a second. That's obviously an interesting country. Let's do Germany now. So Germany's one of the rapidly growing countries, especially after World War II, the 1950s and 60s and 70s. Population growth, though, is almost non-existent. And so consumption equivalent welfare growth in Germany is one of the lowest in the world. Okay. Let me show you that graphically, just because I'm going to show you a bunch more graphs like this. I think they're easier to see than the tables. The blue, these are the same set of countries I just showed you. The blue numbers are per capita consumption growth, right? So the US was 2.2, Germany was 2.9. The green numbers are the V of C times population growth. And then the numbers at the top of the bar are total consumption equivalent welfare growth. So the 8.6 for Mexico, the 6.5 for the US, the 3.7 for Germany. Okay, so you can see the size of the green bars relative to the size of the blue bars. That tells you again something about the importance of population growth here. Okay, 10 more minutes, and then I'll stop and open things up. Blue bars here are per capita consumption growth. Brown bars are total consumption equivalent welfare growth. These are percentiles. Where are you in the world distribution of growth rates, right? Mexico, South Africa, and Kenya, if you just look at consumption growth, they're in the bottom third. If you look at consumption equivalent welfare growth that takes the population into account, Mexico rises to the 88th percentile, I think, South Africa, the 75th, Kenya, the 60th or 65th. Other countries move down very sharply. So Germany, Japan, and China are in the top quarter of the growth rate of per capita consumption. But Germany's in the 10th percentile of consumption equivalent welfare. Japan's around the 33rd percentile, and China's below the median, right? China's this incredibly rapidly growing country in per capita consumption terms, but because of their low population growth multiplied by low level of consumption, they're slightly below the median for consumption equivalent welfare growth over this period. Here's all the countries. Let me skip that. Here's if you give every country the same VFCs. So the average was 2.7. Give every country the same VFC. Let me just point out what it does to Ethiopia. So Ethiopia was here, kind of 4.4. They get tons of population growth, but they're so poor that adding those people doesn't boost consumption equivalent welfare that much. But if you value their kids at 2.7 years of consumption instead, Ethiopia becomes one of the fastest growing countries in the world, right? So how you value those people definitely matters for particular countries. Let's see, let me show you, actually, let me go to individual countries, I think. So here's the growth rate in Japan by decade, right? And you can see it falls from 9.7 to negative 0.3 since 2010. And it's really, partly the slowdown in consumption growth, but also the negative population growth is doing a lot of work in this last decade. Growth rates in China. Okay, in the last few minutes, let me show you some other things. So here's the US. Oh, sorry, John, go ahead.
There's sort of a hint here that Japan did badly, but surely you've already made the production side point that you're not thinking production side, but of course, Japan probably could have grown population more and kept its per capita doing okay. So it's not necessarily that they did it badly.
Oh, I don't want you to miss it. This will take 2 seconds.
Yeah, that's an interesting question. So we need to mute someone. Who is it?
So if I could teach my
I don't know if I can do this here. Oh,
well.
Who is it who doesn't have their mute
it's
on?
Cascade Judson.
I'm not an administrator that handles the class location, so
If they say it's okay, then it's
sorry,
okay.
Cascade, can you mute yourself?
if the,
Patty.
yeah,
Oh,
Let's
good.
see if I can.
Yeah,
do this.
so
I'm getting mixed.
I think whoever's the host can do it. So John,
Yeah, I'm the host,
Well,
but I got to figure out how to do. I'm on
the
this.
people that
go
run
to
the building
participants and
stuff
click on that.
decide who can schedule stuff where. So Cheryl's been in touch with the people from Anderson School,
Oh
and
gosh.
they had told her
Here
they're
we
trying
go.
not to,
Right.
they're trying to avoid scheduling
do this.
undergrad
As much as
classes.
possible.
Yeah, I mean, that's not,
Okay.
If
I
you're
decide
okay
who
with
to
it.
hire in curriculum.
Oh, there we go. Good. Yeah, I mean, certainly it's an interesting question from the social planner standpoint. The social planner wishes Japan had used some of its productivity growth to have more people. I think that there's some misallocation in some sense relative to our social welfare function, but yeah, Japan's obviously a fantastic growth miracle on every dimension.
From what you've done, there's no sense that Japan couldn't have had more people and exactly the same consumption per capita.
Well, people require resources, right? You have to have them.
Well, but people
you
produce
have to raise
resources
them.
too. Anyway,
Yeah.
just from what you've showed us, you said this earlier, but there's nothing about the production. But it could be that in fact,
Absolutely.
from what you told from your other work, maybe having more people would have raised consumption per capita.
Yeah, absolutely. Okay, let me show you a couple of other points in the last 5 minutes. So here's the US using the Barrow or Sua data back to 1820. You can see that the green bars are really big. Of course, there's a ton of immigration coming to the US, right? And so this is where, we're assigning the immigration, we're giving that value to the US consumption equivalent welfare. In levels, it really matters. So here, I'm just accumulating those bars. So I'm showing you the levels instead of the growth rates. Consumption per person in the US is 24 times higher today than in 1820, 1.6% per year. Aggregate consumption is 800 times higher. We have a lot more people as well, right? So 3.4% per year. And you can take the difference to see the population growth rate. Consumption equivalent welfare. So aggregate consumption would give you a factor of 800 instead of 24. Our consumption equivalent welfare gives you a factor of 600,000, right? 6.7% per year. And so, it's just a massive difference when you value people the right way instead of valuing people, say, even with aggregate consumption. But you've got this immigration question. And so maybe we're overstating it for the US. So the second part of the paper looks at adjusting for migration. And you can do that by sort of simple things like looking at the West instead of the United States, where you get a factor of 3,000 instead of a factor of 100. So again, it makes a difference. It's stunning how large, the values are, like the 3,000 versus the 100. You do the world as a whole, where it's 3,700 versus 316 going back to 1,500. And then you could do this sort of what I was saying. You can assign the migrants to their source country rather than our default assigns them to the destination. You can assign them to the source and ask what difference does it make? And it turns out not to make a ton of difference. So it can be, plus or minus even 2 percentage points for the biggest movers. Let me show you some of those countries. So, the United States, rather than being, kind of 6.5 or 7, whatever it was, this is a different period, would be down by 0.5 percentage point. Hong Kong would be down by maybe 2 percentage points. France, Germany, the UK. What about Ireland and Mexico? Well, they're a source for a bunch of migrants. And if you give them back to their source, it adds maybe a percentage point or 2. Philippines too. So the migrant adjustment, it's important, but it's not that important. It doesn't really change how you're looking at things. In the last 3 minutes, let me say what we do at the end, because this has come up a little bit in different ways. And it's worth seeing we're in the process of doing this. It's not totally complete. So slower population growth due to falling fertility, that could be compensated by higher per capita utility. We're having fewer kids, but they're higher quality kids. And notice the kids aren't entering that utility function so far. It's just a U of C. But you might say, why do parents have kids? It must be that there's a kid thing in the utility function, and we're missing that in what we've done so far. So here we're going to put kids in the utility function, and we're going to add a quality-quantity trade-off and leisure. And so we're going to have parental altruism and then privately optimal fertility, consumption, and time use by parents. And so our social welfare function now depends on the number of parents, the number of kids, the consumption of the parents, the consumption of the kids, leisure of the parents, human capital of the kids, and the number of kids. And we've broken it out into the parent utility function. Sorry, this would have been more helpful. The parent utility function, and then the kids utility function at the end. And we put in some production functions for where kids come from, and we put in some production functions for how parental time and goods translate into human capital. And we let parents pick their fertility rate, pick their B, and we respect these first order conditions and redo our calculations using time use data. I guess the time use data here. There's our baseline. Let's see if I can click. Okay, click. Oh, here's the baseline. And then there're just extra terms for leisure and quantity of kids and quality of kids. And the question is, does it make a huge difference? And if it made a huge difference, we'd be nervous. We'd like it to make some difference. We think it probably would make some difference.
Chad, do you use the observed fertility to discipline these?
Absolutely.
Okay, so this addresses the question, wait, if kids are so valuable, why aren't people having them?
Exactly. So we're writing down a model where people choose how many kids they have, and we're matching the data on how many kids they have. Exactly. So
could you remind me again what you mean by quality of kids?
Quality of kids is their human capital. It's going to be the production function depends on how much time you spend with them and the parental human capital as well. I think we don't have education spending in this version. We just have time. Parents spend time and their own human capital to produce kids' human capital. And that affects kids' consumption in the future.
And this gets at some of the issue that more people isn't free because you got to educate them and bring them up.
Absolutely. That's what we're missing in the first part. The people kind of come for free. And here we're sort of recognizing, no, people exist because parents choose to have them and they invest in them. And what if you take all that into account? And so we're using these time use surveys so far. So we're limited for the countries based on where can we get good time use data over time. So far we have the US, Japan, the Netherlands, and South Korea. And for different periods, the Netherlands goes back the furthest. And here's what we find. So the baseline is the numbers I showed you before, and it's over a different period. So that's why the number is not the 6.5. The extension is what I just showed you on the previous slide, And then these are the contributions of those three other terms that add up to be the difference between our baseline and the extension. Okay. And what you can see, just eyeballing these things, it's kind of plus or minus a few percentage points. Right. So for South Korea, it's 0.5 percentage point. So that's big. For the US, it's 0.4 percentage point. But it doesn't really change the overall picture. And you can see, in the US, parental leisure is going down, so that's a loss. The quantity of kids is falling, not by that much, it turns out, so that's a loss. The quality of kids is going up, but quality and quantity tend to offset here. So that's part of the intuition. Quantity is going down, quality is going up, and more or less, it leads to not such a big difference. Just to summarize the not such a big difference, if you asked what share of consumption equivalent welfare growth is due to having more people, here's the baseline and here's the extension. It kind of across these countries, it just doesn't make that much difference. And so this gives us some reassurance that the thing we're doing for the 100 countries, which is missing a lot of the subtleties that you might want to include, we're thinking that those subtleties don't really change the story.
Ted, I think you're missing the human capital you give your kids then is more productive in the future. So in fact, this could be even if you put all that human capital in your kids, it's just because you love them and they're going to be happier because they read Shakespeare. But actually, if you taught them to code and they produce great stuff, this could be a understatement of the value of having more kids.
Yeah, notice that I think what we're doing has that in it already, because we're looking at the flow of utility in 2020, right? And the kids' human capital is going to show up as their consumption when they're adults in 2030, right? And so it doesn't show up today, but it would show up in the future. And so if we're measuring parents' consumption accurately, it's kind of already in there. We're just the source of it is through the human capital.
Got it.
Yeah. Okay, I'll have one more slide, which is just the concluding slide, and then I can open up the questions. So what do we take away from this? I think the big picture is it's shocking to us how much population growth matters. I'm a growth economist. I love per capita consumption growth and per capita GDP growth. I've spent my whole life studying those things. I think that's all really valuable. But it's interesting how in many countries and time periods, that adding more people is just incredibly valuable. And if marginal utility is falling the way our standard utility functions suggest, it's becoming increasingly valuable. And so it's not a stationary thing. That V of C rises over time. And so the value of people becomes ever more important. It's already kind of 5 times as important as consumption growth on a weighting, or 2.5 times for the average country. And then thinking about sort of subtleties that we might have missed in the simple calculation, the migration, or parents have kids because they love them and choose their quality quantity. All that stuff seems potentially important, but not first order for the answer to the question. Okay, let me stop there and open it up for any more questions.
Okay, so my sad task is try to moderate the questions in the order they come in. So I think Jonathan went first, and then I've got Anoop. David went and then took his hand down. So go for it, Jonathan.
No, I didn't take my hand down. I applauded. Thank you.
But Chad, I think the right way of looking at this is what John said, which is just what's the implication of N times U, and see what it is. But with that said, I've just gotten back from South Africa, right? And so adding a hell of a lot of people in very low poverty, there's just something about that it doesn't seem right, even though I agree, if we're going to think about those people not living at all, we have to think about what that means. So I guess my question to you is, ultimately you're going to have to deal with a question of what preferences and what is a preference in this environment.
Yeah, no, for sure. I think we're explicit about that. I mean, we do the U bar plus log C. Notice our framework totally agrees with you, by the way, right? Our framework says if you can add a person, where you want to add them, the US or Ethiopia, far and away you want to add them in the US. Notice with these preferences, it's possible to be so poor that you'd rather kill yourself, right? So the utility from adding people in the poorest country in the world can basically be zero. The value of the V for Ethiopia in 1960, I think, is like 0.3 or something. It's just adding, they're so poor that adding lives there is just not doing much for the planner. And if you think about the income distribution in Ethiopia rather than the average, there could be people there who are, is their life worth the not living? By revealed preference, not, but it can be, arbitrarily kind of small. So I think the framework includes
technically, you don't say they would rather kill themselves. It's just not worth a lot of aggregate consumption to bring them to life. It's always worth something. It's positive.
Well, interestingly, there's a great Sherwin-Rosen point on this from one of his papers in the 1980s. He was one of the early people thinking carefully about this kind of framework for valuing, life extensions and risk and risky jobs and things like that. And what he's think about the utility function U equals log of C, right? U equals log of C passes through 0 at C equals 1 and turns negative. Right now, I add 5 to that, but it turns negative at some point. And so if your consumption is sufficiently low, you get 0 for dying, and you can have negative for living. What Sherwin said is what you'd see is people would be risk loving and they would convexify the utility function. They would take gambles. We'd all sign up and we'd say, okay, half of us are going to die and the half who live get the resources of the half who die, so that you sort of linearize the utility function between 0 and it turns out V of C equals 1. So V of C kind of, if you take Sherwin's approach, V of C can never be less than 1. But that's whether you think those lotteries are things people can do.
And whether the level of utility matters to anything. But anyway, Anoop, I'm vastly abusing my privilege here. Anoop, please go ahead.
2 questions. One's a small data question. So you're valuing, human capital production is just the parent spending time. A lot of countries you have additional investments, human capital, schooling. You think putting that in will change a lot, the kind of the numbers you're getting? I'm assuming the answer is going to be no, because pretty robust results so far, but do you want to get your thoughts on that? That's my first question. And then
it's a good question. We've been slowly working through this third part of the paper and adding things and figuring out how to add things. And so we haven't explored adding, goods as well as time to the production of human capital. I think it's potentially important. I think we had this intuition early on, which turns out to be wrong, but I think it's still helpful. In some sense, parents are going to have kids until the quantity, there's an envelope theorem about the quality quantity trade-off that says parents are going to be kind of close to indifferent somehow. And that kind of suggests that you may be adding a 0 to our baseline calculation. That's wrong for various reasons, but I think it kind of helps think about why we're getting small additional effects. And I think if you added, the spending on education as well, you'd probably get the same thing, but I don't know. It's a good question.
So the second question is, one of the things that, so when you think of long-term growth going back in time, you got the pre-Malthusian, simple models, and then you've got the change after the Industrial Revolution. And then we try to write models down that tries to fit both of them. And now, if we were to think about that problem in this context, how should we think about going from a time where you spent virtually every extra dollar having kids and no additional per capita income beyond subsistence, to a period where you have substantial growth in per capita income and less growth in people, even accounting for quality investments?
Yeah.
Should we think about that earlier period differently, or that just it's kind of in there?
I think so. I think a big picture point here that applies to this question and some of the other questions, when we look at equilibrium outcomes in the economy. So I'm totally on board with that. None of us are maximizing N times U of C, right? We're all maximizing U of C. And so there's a big externality here that in some sense we're all ignoring according to this approach. I don't know if I believe that fully or not, but that's what this approach says. I think it's worth entertaining. There could be a huge externality here. But the history of the world is about individuals maximizing the U of C and ignoring that N times U of C. They're having kids, partly because they couldn't control their fertility, and this is what evolution kind of primed us for. Then I think, to your point, I think the Malthusian point plus the Romer point is how we understand that hockey stick of history. That, diminishing returns to land meant every time we invented fire and the Bronze Age and agriculture, we ate it up by having more people. The ideas came so infrequently that kind of we were in this Malthusian world. I don't think anything had to change. I do think things changed, but if you run a Romer plus Malthus model forward, and that's sort of Michael Kramer or Ronald Lee were the first people to kind of make this point, you don't have to do anything special. It gives you the hockey stick. And it's just, people produce ideas. And as we add more people, those ideas come sooner. It used to be it took 1,000 years to get a new idea. But once we've got a large enough population, we get the ideas sooner and sooner. And so you kind of get that hockey stick happening just from larger populations.
But what you're saying is, to understand history, we need the production side as well.
Absolutely.
By maximizing U of C, we unwittingly ended up maximizing N times U of C. It's just because the ideas.
Yeah, I don't think we did end up maximizing N times U of C. I think we're still maximizing.
We did a good job. We did a much better job.
It's an interesting question. So to answer this question, you have to bring in the production side. And I think it is kind of the next project that I want to think about. Like, what if you bring in people produce ideas and there's pollution, but we're ignoring this externality, and how does it all decompose in an accounting, economic sense? So
David.
Yeah, great paper, by the way. I wrote you a personal note saying that. So this is more just a test for me of my own understanding. I'm going to go back to this immigration point, and it relates to something you said a minute or two ago about you could have such low consumption in Ethiopia that it's not worth living. That's hard for me to believe because you're living, but it could be very low value.
Yep.
So, people often say we should have some kind of a point system for immigration to the United States, get people with high human capital. With this, all other things equal, which aren't because of the production point John Cochran made, but all other things equal, would it say we should get the poorest people from Ethiopia to come here?
I think if you're writing down a social planner, social welfare function like this, yeah, you'd be tempted. The people who can benefit most are the poorest people of the world. I think that's probably right. And the benefits are huge. I mean, you probably know this work already, but people like Michael Clemens and Giovanni Perry and other people have done these calculations, and they're just enormous gains from letting poor people move to rich countries. It's a more subtle problem than that, but it's definitely important to appreciate that the gains on the table are potentially huge, and so that's worth thinking about.
Thank you.
John Cochran is muted.
The echo of the Zoom age. If no one else has any questions, raise your hand or speak up if you do. With that, thank you, Chad. This was a wonderful presentation and very thought-provoking paper. There's nothing I love than something that completely unsettles everything that I thought was settled. You have certainly done.
Thank you all for your comments and suggestions and questions. Those are all really helpful, and we'll work to incorporate them in the next version of the project.
Great. Triple applause.